Let's talk about galaxy clusters, Virgo, C1 and C2. Clusters are a big collection of galaxies. We have hundreds of galaxies, thousands of galaxies inside a cluster. There are three clusters in your assignment, Virgo left and C1 and C2 right hand side. First thing, without doing any calculation, if we assume all three clusters have the same true size, by increasing their distance, they will look like smaller. So you can compare their size and you can tell which one is further, which one is closer. Let's do the calculation. We have Virgo and we have C1 and C2. For Virgo, we need true size. We have angular size, we have the distance, and we need true size. So we have the same formula for distance and angular size. We start from theta. For theta, we should use theta in radian. But problem is we have theta in degrees. So first, let us convert from degrees to radian. We take theta in degrees and divide by 57.3 and we get theta in radian. This is our first step. This theta in degrees is given. It's the problem. Theta in radian is used for true size. For true size, we have to play with this formula a little bit, but it's distance multiplied by theta in radian. It's just two numbers. Theta in radian is here, and distance is given. Distance is in megaparsec, and we don't have any unit for radian, so true size in megaparsec. You don't need to convert anything. Next, we need the scale. We need this scale for C1 and C2, but we should use Virgo to find the scale. This is the Virgo. For Virgo, we have true size, and we have angular size, and we can measure the size using a ruler or scale. So this scale is equal to angular size in degrees. We have this number divided by the same size in centimeters. You should use a ruler to measure this length. Okay, now C1 and C2. For C1 and C2, we need distance. First assumption is they have the same true size. So SC1 is equal to SC2 is equal to S Virgo. We have S Virgo, and it's the same number for all three clusters. We also need the scale, and it's the same number we have in section B. Now we can put all together to do the distance. For distance, we need theta, we need angular size. But we don't have angular size. For angular size, we can use the scale. So theta C1 is equal to the scale multiplied by the length for C1. For C1, we use a ruler, we measure this length in centimeters, and this is the scale. So just measure side to side. Now we have theta, but this theta is in degrees. Again, we have to convert from degrees to radian. Theta C1 in radian is equal to theta C1 in degrees divided by 57.3, the same number all the time. And now we have this number in radian. Using this number, we can calculate the distance. Distance is S divided by theta. Theta is here, and S is the same number for Virgo and for C2. For S, we have megaparsec. So for distance, Our unit is megaparsec. Size and distance are in megaparsec. This is for C1, and you should do the same thing for C2. Everything is the same. Measure the length, multiply by scale, find theta for C2, convert to radian, use the same formula to calculate the distance. Okay, let's summarize what we did here. There are three clusters, Virgo and C1 and C2. For Virgo, we need S and we need scale. So we use Virgo to find true size and scale. We use these numbers to calculate the distance to C1 and C2. So just don't be confused.